Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. In the previous lecture, we discussed about how to access the fields of a Java object in C++ using JNI. And we said that it's very similar to how we do it with Java Reflection API. So we have to get the class that has the meta information of the object, and then we said that we have to then get a field identifier from that class, and then we can call the field.get and pass in the person object. For example, in this example, it's the object of type person, and this returns the value of the field as an object, and then we can typecast it. If it's primitive, we don't need to. We can call the field.getInt or getDouble using the Java reflection, and it directly returns a primitive type, okay, that has the value of the primitive field of the object. And then we said that this is extremely similar to how it's done in JNI using C++. And the first step was to, if we want to access an instance field of a Java class or Java object, after we instantiate the object in C++, we say find the class, and we give it the class path of the class. So this find class returns the J class, a class that has the meta information, and it's not associated with an object, an instance of an object. It's associated with a class. And then we get the field ID from that class, and again this field ID is associated with the class itself. It's a general property of, for example, this person class. And then from these two, basically now we can pass in a J object and then J field ID. So now we pass the instance of the object that we want to get the actual value of the field. And then we already have the field ID. We pass them to the JVM, and depending on whether it's a primitive field or an object field, then we call either a get object field or a get double or int or float field, any primitive type, okay? And if we return a J object, then we can typecast it to, let's say, J string or something of that type, okay? For example, here the name was a string object, but in JNI, in C++, I got a J object when I invoked the get object field, and then I typecasted it to J string and then asked JVM to give me the actual characters of this Java string, and then I printed them. But what about the static fields? Static fields are pretty much similar. So again, now assume that our person class has a static field called name, which is set to Bob here, for example. So this is a static field, so it's not an instance field. So if I instantiate different objects of type person, all of them have the same property, Bob, because this property, this field name, is not associated with the state of the object. It's associated with the class. So the very first time that the JVM loads this person class into memory, this field name gets the value of Bob because it's a static field, all right? So again, we need to get the information about this field by getting the field ID. Basically, field ID is the identifier of this field for this person class. So again, we find this class on the class path, and this returns a J class. And then we get the field ID associated with this field for this class. All right, name and signature of the field. And now we ask the JVM to get the static field for us instead of saying get object field or get double field. So we just add a static to the function that we call from JVM. So if it's a primitive type static field, we say get static double field, get static int field, etc. And we pass in the J class and the J field ID. If it's a static object, if the field is of type some sort of object, then we say get a static field. Instead of saying get object field, we say get a static field. And instead of passing the J object, which is the identifier of an instance of the class, we pass a J class, okay, which is the identifier of the class, because static fields are not associated with the instance of the class. They are associated with the class itself. So we pass the J class instead of J object. And obviously we need to pass the J field ID so that the JVM knows which field we want to get. And we can also do the proper casting. And again, this is similar how we do it in the Java reflection. So in Java, for a static field, I start with the person class and get the class object of that is associated with the class itself. So now this is the class, not the instance of the class. So previously we created an instance of the class person, and then we get the class that is associated with this instance of the object, instance of the person class. And here this class actually has the information about the static and instance fields, but now we just want to get a class that only has the information of the class, all the static fields or the static initializers. So I just directly get you start with the class itself and dot class, get declared field name. So this returns a field identifier, and then we can say f.get, and instead of passing an instance of a object person, right, instead of passing an instance of a person, I pass in the person.class itself, right? So the difference now is that we are working with the person, but note that the capital P is not an object. So this function f.get needs to have a object as the parameter. So we cannot pass person because person is not an object, but person.class is an object, right? So we can just pass it, and then it returns an object which is a string, so we can typecast it. So let's head to Eclipse and try to start with the Java and the reflection. So I'm in my Java perspective. So I'm going to create a new package. Let's call this test8. And I'm going to start with my person class. So I'm creating a class person, and then let's create a static field, a string name is Bob, and also a primitive type, a static int age 21. All right, and we don't need to have any constructor. The default constructor is already there. The compiler puts a no arg default constructor for us. And now let's create another class called test static field, test static fields. And here in the main, I'm going to create a method called test1, and this test1 is going to be public static void test1. All right, so what do I need? I need to basically create a class of whatever type. Class is person. This is the actual name of the class dot class. Okay, so this returns a class of type person, right? And then I can say basically now I need to get a field f. Let's call this f1, class dot get declared field. And remember, I'm using declared field because if I use get field can only access the public fields, but here these have default access modifiers. So these are package level access, these are not public fields. And let's say this is name, right? The name of the field is name, and I need to import the field. Just be sure that you import the field from java.lang.reflect. So we are going to import the field from the reflection package, java.lang.reflect. And this throws a bunch of basically exceptions. It's a no such field exception, which is obviously we expect that because the name might be wrong and the class might not have such a field, such a name for the field. And security exception, for whatever reason we might not have even enough security to access this field. And now I'm going to also throw them out of the main. Okay, so let's sys out the field f1. So it tells me it's a static field. The type is java.lang string, and its identifier is from package test8 for the person object, and the variable name is name. Okay, so these are all the informations. And for example, if I have public static, I add the access modifier. The fact that this one doesn't have any access modifier, it means it's a default access modifier or package level. So if I add public, it also tells me that it has public access. Okay, public static, the type is a string, and the variable is name. So let's just remove this public for now. So just the difference here, now I'm using person.class, so capital P. This is the class itself. And this class object that is returned, it has all the meta information about the person class, anything that is associated with the class, not the instance. I didn't instantiate this person object, person class, right? So obviously in the next step to say f1.get, and we're going to pass in an object. So can I do this? No. Why? Because the capital person, this is the class, not an object. This f.get expects an object. So I just pass in this class object, all right? And this also throws exceptions, illegal argument exception, illegal access exception, and this returns an object. So object, name object, okay? So again, I cannot pass the person, the capital P person, because it's a class, it's not an object. But I can pass in the class that has the meta information of the person class. All right, I can do this. And now I already know that this is a string, so I can typecast it to the string, a string name object, and then I can do a sysout on the name. And I should get the value of Bob. So we have to also throw these two exceptions out of the main. So we are good to go. Yes, so Bob. All right, so what about the primitive type? So this is the primitive type, and this was the basically object type, a Java object or Java class, and this is primitive. So again, we get the class that is associated with the class person itself, and we obviously need to get the field. So class, or maybe it's just easier to do this, or we can just use the class and then get declared field, and it's called age. So this field is the identifier of this basically of this field, in this static field inside the person class. And how do I know it's a static field? Because I'm invoking get declared field on the class that is associated to the class, not an instance of an object. All right, so we are getting this from capital P person.class. So if I do a sysout on the F2, I get a static int, and then the name is age, which is associated with the capital P class. All right. And then finally, I can go here and say int age is f2 get int, and I have to pass an object. What object? There was no object. I didn't instantiate any object, but I do have an object that's actually the class object that is associated with the person class. All right. This is how we get the static field from the reflection API. So we have to pass the class object that is associated with the person class, and then we do a sysout on the age, and we get 21. All right, so this is how we do reflection API for the static field. So we use class that is associated with the class person, not with an instance. All right, and then we invoke the get declared field on the class. So now let's create a native method. Let's call this public native void, basically print info. We want to print info, which is, so we pass a print, let's say print person info. So we don't pass anything, so we are not going to pass an instance of an object, and then we just want to print the static information, static fields of this person class, and we're not passing anything to this method, right? And then I'm going to have a method here, public static void test2, and in test2 I'm just going to say print person. Now obviously I need to, this is not a static method, so let's just create an instance test new, all right, and then test dot get print person info, and then I can run test2. Okay, now at the moment it's going to throw the exception unsatisfied link error. All right, so I have my native method. I'm not passing a instance of a person object because I just want to access the static fields of the person class, not an instance. So we select our so let's go to our C++ perspective. So we select our Java that has a native method and then run the Java H tool, and this creates the header file, and I have already configured it to put it inside this basically header folder. So it is there. So this is my header file, and then we go to our source folder and create a new .cpp. Let's call it static fields .cpp, and the very first thing is to include that header file .header test8. all right, and then we copy and paste our the prototype of the function, the JNI function, and we have the environment, and this is an instance method, right? So we always have a reference to the calling object. So the object is test static field, and this is an instance object, an instance reference, the reference or the memory address to an instance of this class. But we don't care about that. What we want the, first of all, step 1, J class of person. So we tell it, hey, JVM, get a find this class on the class path, find class, and what is the name? We have to pass the basically the class path name, which is the package/class. So it's in test8, the class name is person. All right, so the JVM goes and one code here. So the JVM goes and looks into the class path, find on the class path. All right, now obviously if it can't find it, it throws an exception, class not found exception. And basically, in order to show you, let's say person with an S at the end. All right, and let's compile this. It compiles fine, and then let's copy and paste to our Java JNI folder here. And then in this test static field, I need the load library using a static initializer, system.load library, native _C. And let's run test2 to see what happens. So it says no class def found error, right? It says the JVM says I couldn't find the test8/persons because there was no person, right? So we just correct it. So if JVM cannot find it on the class path, it just throws an exception, no class def found error. All right, so back to our C++. So step 2 is to get the field identifier, JField ID, of the field that we want. So JField ID, let's say name field, or maybe just name _FID is environment. We're asking JVM get field ID. It doesn't matter if it's a static field or the instance field, doesn't matter. So we have to pass the J class, which is a person class. The name is name. The signature, if it's a string, so it starts with L, ends with semicolon, Java/lang/string. All right, don't forget the semicolon and L because this is the signature of an object. So, and then again, another field ID, let's call this age FID is environment get field ID, and we pass in the person class, the name is age, and the signature is integer, so I. And then step 3 is the get the values. So we know that we get a J object, let's say name object, if we ask JVM to get us the field for this Java lang string. So environment get a static field, get a static field. So let's see, get a static for age. Let's say get a static. So let's start with the age. So we know that it returns a primitive which is integer. JInt age is environment. Get a static int field. We pass in the J class and we pass the field ID, which is age. And then let's just see if we can printf it, and %d \n. So this is age is equal to age. So let's start with this. Let's compile this. It compiles fine. And let's copy and paste to our Java. And then go back here to the test static field, and then let's run test2. And the JVM crashed. So let's see what went wrong. So here we have to basically access get a static field ID. So we pass in the person class, and then the name, which is age, and the signature is integer I, right? So let's comment this. So for the static fields, we use the get static field ID. And let's compile this, and let's copy and paste the dynamic library. And let's go back and run this again. And now it works, right? So the difference here is that in the Java reflection, we don't need to, we just invoke the get declare field on the static class, on the class that is associated with the person class itself. And by default, this means that it should be an static field. But in the C++, in the JNI, we have to manually tell it that this is an static field that we are accessing. So get a static field ID, okay? And then the same thing for the name. So we say that get a static field ID, and then let's see, J object, basically name object is environment, get a static field. So get a static object field. All right, so a static object field. Get the static field which returns an object, not a primitive. And then again, person class, and field ID is name FID. So this returns a static. This is returns an object which is a static field of this class. And then I already know the type, which is going to be a JS string or mapped to a JS string. Name is I just typecast this J object to the JS string, and then I convert it to a const-char pointer. Name array is basically I ask the JVM to actually get me the UTF characters. So get a string UTF chars of this name JS string, and we don't care about is copy, and then I can printf it. So name equals %s and maybe \n and name array. And because this char array is getting created by the JVM on the native heap, we have to ask it to release it. Release a string UTF chars. And the reference or the pointer or to the basically the address of the string is this JS string pointer, which is name. And the characters are the character array, name array. All right. So we manually ask the JVM to release it when we are done with this method and we are going to return. So let's see if this compiles. This compiles fine. Let's copy and paste and then go back to Java and then run. And we get the age 21 and the name Bob. All right. So as we can see, if we want to access the static fields in C++ using JNI, we ask JVM to get a static field. So basically, previously we had, if we go back to test 7, here, a static, basically access fields here. Here we had get field ID. Now we have get a static field ID. Here we had get int field. Now we have get a static int field. We had get object field. Now we have get a static object field. All right. So we just add a static to all the previous names, right? Get a static double field, get a static object field. So it's basically similar to the previous case, but we add a static to hint to the JVM that this is actually a static field. And then we pass the J class, not the J object, right? So here we are passing, again, the J class, the reference to this person class is a J class. But when we wanted to access instance fields, we actually passed in the instance, which is a J object. So this is not a J class, it's a J object. It's a J object, right? An instance of the class. I hope you understand the difference here, because static fields are associated with the class, not the instance, okay? So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.